All right, let's begin.
Yeah, it's like.
So first things first, I posted a review for the first text, so you guys can see that. I sent a mass email about it. Make sure you follow the instructions.
And they wanted like the whole entire number, right?
So don't do anything like look at the answers first and then try to figure out how to get to the answer. No, do it by yourself under timed conditions, and then try to check your work.
And you know, you said that homework was like a different level of difficulty. You meant the homework's harder, right?
Yeah, because the homework will give you like weird numbers and it allows you to count the days in a month. Like I'm not gonna ask you that level, so I don't want you to waste your time doing that kind of thing when you could just be practicing more of the things that I would ask. So when I ask the question, a month is just a solid 30 days, there are 12 months in a year, there are 365 days in a year, etc. So web work will give you weird numbers with things that would require you to go think a lot deeper. I'm not going to ask you to think that deeply. Just want to make sure you know the concepts in general. So it's probably go by the practice problems, and if you need more practice problems, but because you're actually assessing how you're doing, I would probably go to the textbook before going all the way down to web work, and maybe even try another textbook. So there's another class that's very similar to this one. It's Math 1100. They use a different textbook, but it'll have a lot of our stuff in there as well. So you can figure that out. You can find both textbooks in the math tutoring. Anyway, last time we ended with this. We wanted to figure out what this was. Anyone come up with an idea of what that is?
Describe it in terms of the absolute value of A.
Yeah, the size of A and B. Tell me what this is in terms of the size of A and B. I'll give you a hint. One way, I mean, you don't have to prove it. I'm not going to prove it to you, but one way is to actually look at the Venn diagram. The Venn diagram will actually give you some answers, or suggest to you what the answer is. So, A union B, what's shaded? Well, everything in A, right? So it's A or everything in B, or both. So given that, what do you think is this going to be? Yeah. Do we agree? Ah, so see, now he's noticing something in the picture. This is double shaded. What does a set do when you count something double? It ignores it, right? Which means this region over here actually gets counted twice when you look at the size of A and B. How do you account for that? Subtract. Subtract what?
An intersection.
Well, the size of the intersection. That is how you find that. That's an important idea. This is, in fact, it has a name. It's called the Inclusion-Exclusion Principle. This one is for 2 sets. You can actually extend this to many more sets, but the formula gets a little bit more complicated. We won't do it for more than 2. That's going to be important when we're talking about probability and some other things. And we need to figure things out, like the probability of one thing happening or the other thing happening. We're actually going to use this to figure that out. Very important equation. Now, and that just comes from the fact, like we said, sets don't count repeats. So by shading this in, I shaded that twice, so I have to subtract one of those. Now what I want to do is for us to do those Venn diagram problems, the work problems I gave you guys on the handout. So let's go to those. So the first one is the easiest, so I'm going to do that one. You guys can try the others, and then we'll go over it.
Wait, so is this stuff going to be on the midterm?
Yes. Okay. Yeah, there's a problem like this on midterm, which is why you need to make sure you know how to do it. So probably something like A, no, but something like B, something like problem 2, or problem, maybe even problem 3. So I'm definitely going to give you a problem where you need to pay attention to 3 things as opposed to 2 things. But in problem 1, we only have to pay attention to 2 things. So let's look at that. Okay, suppose there are 100 students in a school, and 50 students remember all the math they've ever done. Very good students. Also, 40 of these students are Math 1108 students. Of the Math 1108 students, 20 of them remember all the math they've ever done, and you have to determine how many students who don't remember are not Math 1108 students, and how many Math 1108 students don't remember. So let's actually figure that out. This is actually something you can solve with Venn diagrams. And this is typical whenever you have something like you're given a number of people or objects more generally in certain groups and asked about the number in certain other groups. Then you may be looking at a Venn diagram problem. In the final, I'll have a bunch of word problems, so you want to know how to distinguish when you're reading a word problem and it's a Venn diagram problem versus something else. So basically here, we're given about how many people are in certain groups, and we're asked about how many fall into other groups. Now, once you know you're doing a Venn diagram problem, the first thing you want to do, so step 1 is you're going to define your sets. So notice that there are 2 classes of people really mentioned here. The people who remember all the math they've ever done in their lives and the Math 1108 students. And so I would actually make those 2 sets. Say you can call it whatever you want in general unless the problem itself forces you to call it something. So I can say let M be the set of Math 1108 students. And let R be a set of students that remember all their math. So that's the first thing you're going to do. You're going to call it something. And then 2, draw a Venn diagram. And fill in the cardinalities. Remember, cardinality is just a fancy name for the number of things in a set, like the size of a set. So I'm going to draw a Venn diagram here. There are only 2 sets, so 1 circle. And remember, overlapping them is the more general way to do it, because once you separate the circles, you are saying that I know for sure that there is no intersection. But you leave an overlap just in case. If it turns out there's no intersection, you can always fill in the number 0 here, so it's not going to be a problem. So you do want to have overlaps just in case. Can have mixing. Now, there are some tips in how to fill in this that might make the problem easier or harder. Some tips. 1, fill in places with the most overlap. First, also, spaces. designated only first. So the first positions, the first regions of space that you're going to want to fill in is the places with the most overlap, as long as you know that information. And another place that you're going to want to fill in before you kind of start filling in any of the other numbers is anything that says only. So they might have something in the problem that says, you know what, there are 5 students who take Math 1108 and that's their only group they belong to. They don't belong to the group of students who remember. So sometimes the problem will tell you that. So you're going to fill out anything that says only first. You're also going to fill out the places with the most overlap, and you go successively, right? So if there's an overlap of 3 sets, do that before the overlap of 2 sets, and so on. Another thing is you might also want to fill in numbers in no sets. And of course, you can do all of this, both this one and that one, whenever possible. So it's not that the problem will necessarily give you this information, but if it does, be sure to put that down first, because actually all the other numbers will react to what these numbers are. And so that's going to be important. If you fill in the other numbers before these ones, you can actually get the wrong numbers in certain situations. So we're going to do that. It's very hard. So let's do that with this problem. So we know there are 100 people in the school, so this box, there should be 100 people. All the numbers adding up in this box should be 100. 50 students remember all the math they've ever done. Okay. Can't really do anything with that information because I don't know that they're isolated either over here or over here. So I can't really do anything with that right away. 40 of the students are Math 1108 students. And of the Math 1108 students, 20 of them remember all the math they've ever done. So you see that 20 right there, that's a number that I can fill in because they told me right away how many is in that overlap, right? There are 20 Math 1108 students who also belong to the circle of those who remember. And that's all the information we have. So now what we're going to do is we're going to fill in all the other numbers based on what can be said. So I know 50 students remember all the math they've ever done. So how can I fill out the rest of the remember circle? Come again? Let's fill in the rest of the remember circle. What's that going to be?
30.
It's 30. How did you get the 30? Well, it's going to be the 50 minus the 20 that's already accounted for in this part of the circle. And so that is, there's 30 people over here. So that means there are 50 total people in the R circle, but 20 of them also belong to the M circle. Now we know that there are 40 students in Math 1108, so that's going to tell you that all the numbers in this circle must add up to 40. And this circle only has 2 regions, which means this side is going to have 40 minus 20. That's going to have 20 people. So half the Math 1108 students also belong to the R circle, and half of them don't. Now that we have that, we have all the circles filled in. How many things do we have filled in here? How many people is accounted for?
70.
70, which means there are 30 people out here. So the universe had 100 people, and we've accounted for 20 of them here, 20 of them there, 30 of them there. So that means outside here, there's going to be 30 people left over. So now you filled it all out, and you can double check all your numbers to make sure that everything is fine. If we add up all the numbers in the box in total, all the white numbers, it adds up to 100. There are 40 people in this circle, there are 50 people in that circle, and there are 20 people in the overlap, and that seems to check out with all the numbers. So now once I realize that that checks out with all the numbers, I can move on to the next phase, which is pretty much wrapping up. Answer the questions that are asked. Once you have a fully filled out Venn diagram, answering the questions are actually not going to be that hard. The harder part of this problem is actually filling out the Venn diagram. So 3. Make sure you don't start answering anything until you fully fill out the Venn diagram. Usually I'll ask several questions here. So here I have a part A and a part B. But the thing is, once you actually fill out the Venn diagram, actually answering the questions should be pretty quick. You should take a few seconds for each of these. So, how many students who don't remember are not Math 1108 students? Huh?
30.
So the students, so when it says don't remember, you should be aware that this is the complement of the R circle, so we're only looking outside of that circle. And now when you say it says they're also not Math 1108, it means it does not include this 20, which means it's going to be this 30. Now, there are two 30s here, so let me distinguish which 30 I'm talking about. This 30 here is going to be the answer in part A. Right? That's not in the R circle and also not in the M circle, which they told us they don't belong to either circle. How many Math 1108 students don't remember? 20. So 20 here happens to be the 20 here. So these are the Math 1108 students, so they must be inside the M circle. However, they don't remember, so they cannot also be inside the R circle. It has to be in the group of people over here. So you're just going to look in what position is the question asking you about, and so now what I'll do, I'll give you guys, say 10 minutes to finish up the rest. Or maybe 12. And then we'll go over them together. So do that. Like I said, a problem like this is on the test, so you want to actually attempt to make sure you know what you're doing, or at least know what you don't understand now, so you can ask me questions about it. We'll go over it in 12-ish minutes or so. Okay. So like I said, the test is probably going to be a question like problems 2 or 3. So I'm going to ask you to deal with 3 things at a time, as opposed to 2 things, which problems 1 and 4 ask you about. So yeah. As well as, I don't remember if I wrote this in the review, but on the test, based on the length and the time you have, on average, it's going to be roughly about 6 minutes per problem. So while you're practicing, always kind of keep that in mind and goal. Right? You want to get through every problem you're doing in 6 minutes or less. And of course, if you take longer in certain places, like maybe you might take longer with row reduction, then you know, okay, I'm going to spend extra time over here, but I better get faster on something else. But on average, you do want a 6-minute mark in your head to kind of get through everything in time. That being said, let's do number 2. So again, it's 100 people in a college, and this college has 3 majors: Math, English, and Physics. Okay, the college allows students to have multiple majors, and we know how the majors are distributed. 30 of them major in Math, 40 people major in English, 50 students major in Physics, 10 students major in Math and Physics, 20 students major in Math and English, 5 students major in all 3, 20 students major in Physics only. Okay, and then we have to answer a bunch of questions about how many majors are in some other groups. So, like we said, we are going to define our sets. So, MB is a set of Math majors. Let E be a set of English majors. E be a set of Physics majors. So now what I'm going to do is I'm going to draw a Venn diagram. Now, again, you want the most general setup here, which means you want everything to be overlapping, right? Because it's possible to be more than one thing. So we want a place where all 3 overlap and any 2 will overlap. So that's going to be the beginning here. So here we have the math, physics, English, and the box is our universe. The box is the universe, which is the college in this case. There are 100 people here. Okay, so what did we fill in first? 5, right? Because we know all 3. You want to try to fill in the places with the most overlap first. What else can we fill in? Huh? Well, yeah, but there's something else you should fill in first. What's the next thing that you fill in? The what? Physics only. So that tells us about people who are only physics. So that means that's solidly in this line. So those are the first 2 numbers you fill in this problem. The places with the most overlap and anything that says only. There's only this many people. So I know for sure there are 20 people in that group that doesn't overlap with any other groups. Okay. Let's start doing the rest. So now remember we fill in the places with the most overlap successively. So the next goal is to fill in these positions if at all possible. And can we actually do that? Well, yes, we know math and physics, right? How many in math and physics? So what does that mean? 5. There's another 5 over here, right? So the overlap between math and physics is 10 people, but I've already accounted for 5 of the math people over there, so there are 5 people over here. Math and English, 20, which means, so that was, this is the 15 here, because there were 20 people in math and English, so 20 minus the 5 gives us 15. So now there are 20 people in that overlap with math and English. 5 of those people also overlap with physics. What else do we know? So we know math and physics, math and English. 5 in all 3 majors. Okay, what can we fill in now? Right, we can fill in the physics circle. Here's the physics circle. Notice that it is split in 4 sections. We know 3 of these sections, so there's only 1 more section left. And we know in total there are 50 physics majors. So there are 50 people in this circle in total. We have accounted for 25 and 5 of them. So how many are left over in this section here? There's another 20 people over here. Now, in the math circle, there should be 30 people total. We've already accounted for 15 plus 5 of them, right? So there are 30 people total, but I know about 5, 5, and 15. So that gives us what? 5 people are majoring in math only. How many people are majoring in English only?
0.
0, because English, there are 40 people in English, and we've accounted for all 40 here. There's 0 people. No one's majoring in English only. What's your career? I'm kidding. That's not a stab against English majors. If you want to major in English, that makes you happy. Do that. Okay. But in this college, everyone who majored in English, you know, they hedged their bets. They majored in something else. Okay, so do we have everything filled out now? So now if we add up everything, probably start with the biggest number here. So there's 50 people in this circle, plus 20 people out here. So that's 70 people that are filled in all the circles, which means there are 30 people outside of that circle. Right? So that's going to be 100 minus the 70. So this is our fully filled out Venn diagram. And now we can start to answer the problems. How many students have no major? 30. You can see it right there. Students majoring in math only. There are 5 students in math only. How many students are in math and physics only? 5 here. How many students major in English only? No one majors in English only. Yeah, so that's the correct solution to that. Think we can get through the other one in 5 minutes? Let's try
I
it.
think so.
Let's do it.
Well, you only get
We'll have a minute to spare. Okay, 3. So it's another people who take subjects. A survey of university students found that 64 take math, 94 have taken a chemistry class, and 58 took physics. 28 took math and physics, 26 took math and chemistry, 22 took chemistry and physics, and 14 students took all 3. How many students took one of these subjects only? Okay, so let's just jump into this. I'm going to label these guys on the fly. So now we're looking at math, chemistry, and physics. Okay, what do we fill in first?
Only.
Yeah, so what?
14.
14 overlaps. Okay. All right. Now what?
Do math and physics, so.
Let's do math and physics. Where is that? 28 do math and physics. So if there's 14 here,
14 there.
you must have 14 here. So that's 28 total people doing math and physics. Math and chemistry. There are 26 people in this group. So if there are 14 of them over here,
12.
there are 12 people over there. Chemistry and physics. This group. So there are 22 people, and so we must have 8 here. Now 64 took math, right? So how much is left over here? So it's going to be 64 minus all of these guys, which is 24. And 94 took chemistry, so it's going to be 94, subtract this, subtract that, subtract that.
60.
60?
Yep.
58 took physics, so 58 minus this, minus this, minus this is going to be here. 22. So that's this. Now, we don't know any information about the universe. We don't know how many total people were surveyed. But the question here is, of course, asking about those who were surveyed. How many took one subject only?
106.
Huh?
106.
106. So this means it's physics only or math only or chem only. Now, this is going to be a counting principle for us. Usually when you have or that is disjointed, you pretty much add them. So this is going to be the 22 plus the 24 plus the 60, which is 106. Is going to be the answer. Oh, that was 3 minutes. So we have like 3 whole minutes to spend on row echelon. Just 3 extra minutes on that. Okay, I'll see you guys then.
Thank you.
Today? Yeah.